Welcome back. Let's take a look at how we can use Brownie to pull historical blockchain data for analysis. We're looking at Curve's flagship V2 pool here, TriCrypto. TriCrypto allows for seamless trading between Tether, wrapped Bitcoin, and Ethereum. And most impressively, it does this using an internal oracle. So we've covered this a few times in our previous Brownie tutorials. This is never calling any external oracle, rendering it a bit resistant from flash loan attacks. How's it done? We've got about 6 months of data. We can actually analyze and see how this price oracle has tracked the price of Bitcoin over time. We're going to write live code here, a Brownie script that we could use for the purpose of pulling some historical TriCrypto data. And you can leverage this to pretty much any application that you'd like. So with Brownie scripts, we need to import Brownie. And we're also going to be writing this data to a CSV, which will then import into our Jupyter notebook. Whenever we're dealing with a Brownie script that's looking for a main function, first things first, we'd like to pull in the TriCrypto contract. We can grab the address right here. And as I mentioned, we're going to be iterating through different block heights. So let's take a look and see where we're going to start from Etherscan. So we'll pull up the TriCrypto contract. We'll see the transaction it was deployed at, and anything after block 1282, this should exist. So we'll make our life easy and do increments of 100,000, starting at block 129. We're going to make the choice of pulling the various TriCrypto balance data at each of these points. That is to say, if we had exactly 30 LP tokens, how much dollars, how much Bitcoin, and how much Ethereum could we buy? And because we're data mining, we're going to create some nice labels for when we import this into our Jupyter notebooks. So we know TriCrypto uses 3 coins, dollars, Bitcoin, ETH. And for each of these, we like to pull spot data on the price, as well as the amount of LP tokens we could receive at that height. Now we're going to instantiate our data object. Our data object is going to be what ends up getting written to CSV. We'd like to start this with a header. So we'd like to say that our first row is going to be a list of lists. This first list will be all the header columns. We start with block, and then we're going to permute all these together to get all these 6 combinations of these. We'll do this in inline syntax. In other words, we loop through coins, and then we loop through the suffixes. All right, now we're going to run the first of our 2 loops. We're going to loop through all the blocks that we're going to look at. As mentioned, we're going to increment after everything 100,000 each time. And we'll print out the block at each iteration to see where we're at. So within this particular loop, we're going to prefix all of our variables that are pertinent just to this loop with the underscore. So underscore row, we're going to initialize each loop as the first entry in our CSV, which is block. And then we're going to loop again through the 3 different coins. Or if you like, you could loop through this coin array. The first thing we'd like to get is we'd like to get the TriCrypto.coins decimals times 10 to the 8th. This is what we're going to divide everything by to make the units human readable. We could hard code these decimals instead of calling it each time. We're just doing this to make it abstract, so this could be leveraged towards any V2 pool. The first thing we want is our price. So the price is going to be different if we're dealing with I equal to 0, aka Bitcoin ETH, or USD. There's only 2 price oracles for these 2 coins. And it's off by 1 index. So in other words, we want the price oracle for the coin that is I minus 1. So the first time through Bitcoin, second time through ETH. And here's where things get fun. When you're dealing with alchemy or any particular Infura type service, if you have a archive node, you can pass block identifier to Brownie to run the transaction at a lower block height. In other words, generally when you're running this, it's going to give you the most current data depending on what current block height you're running at. But as we run through this on these different block heights, we're able to pull through the historical prices. Small typo here, the price is equal to that. Second price is going to be equal to 1 if we're dealing with dollars. And the last thing we want to do is we want to pull this amounts. So the underscore amount is equal to calling the try crypto calc withdraw 1 coin. We're going to withdraw 30 LP tokens for this particular coin index at the block height. Now we need to also divide each of these by the appropriate decimals to make it human readable. This one is just divided by 10 to the 18th because that's the units that TriCrypto uses. And this is divided by DEC, which we set right here. So now that we've got all of these, for this row, we will append the price and the amount that we've calculated. And after we run through all 3 coins, we'll append this to our overall data. And presuming no typos, then we are set. The last thing we need to do is we need to open our file to write this data. So we're going to use the CSV module that we imported. And for every row of our data, we are going to use the writer to write this particular row. Now let's see how we did. We're running this in a mainnet fork alchemy. Usually I get at least 1 typo. Coins is not defined. It's correct. It's a 2 typo morning. It is not. So while this is running, this is going to quickly run through and pull the data for us. You can see it's moving fast. In the meantime, let's pop over to our Jupyter Labs. Here in Jupyter Labs, we are going to be importing pandas and matplotlib. You can deal with any program that you like for analysis. And once this is done, we're going to pull in the data using the pandas's read CSV function. You can see trycrypto.csv has now been saved. And here's what our historical data looks like. I'm going to expand this out a little bit. You can see here what we've done is we've pulled from the most ancient block to the most current block at units of 100,000. You can change that units as you like in your script. And way, way, way back when you could buy Bitcoin for 38,000, and then it spiked as high as 64,000, and now it's back in the doldrums. And throughout this time, the effect on 30 LP tokens would be that you could, at the very outset, it would cost 1.04 Bitcoin to be able to buy 30 LP tokens. Then when Bitcoin got expensive, of course, you could only buy 0.94. But then as the price of Bitcoin plummeted, you'd go back here. And of course, we see the sort of inverse happening with USD amount, which is to say at the very earliest stage, it would cost you $40,000. When Bitcoin got expensive, Ethereum got expensive, you could buy 30 LP tokens. It would cost you a lot more USD, but you could get a bargain at Bitcoin ETH. So for this reason, when Bitcoin prices and Ethereum prices go up, if you suspect it's at a high and it might go down, it kind of makes sense to buy into TriCrypto using these volatile assets. That is to say, if you manage to know that 64K Bitcoin and 4,700 Ethereum was the peak, you could have bought into TriCrypto. You could have got 30 LP tokens for a price of 12.9 Ethereum. Then as the price collapses, you sell off, you cash back into Ethereum, and you end up with 15.4 Ethereum at the most recent block. Conversely, if you think that it's at an all-time bottom, you would want to buy into TriCrypto using the dollars, and then once it gets to the top, you might sell out. So this is a way that you can actually, if you want, hypothetically play the market. And now that we have the data in here, we can run any number of analyses that we like in Jupyter Labs. So if we want to track the history of the Bitcoin price, we can plot it here. And anyone who's been following the markets for about the past 6 months knows that this is a fairly accurate mapping. Bitcoin price started around here, soared, and dropped accordingly. So if you want to run more sophisticated analyses, you could, for example, pull in live price oracles and see how close this ran. You could run any number of analyses based on this. This is just to get you started. Of course, some people like to import Brownie directly and run this in Jupyter Notebooks. My computer is a little janky, so I haven't got that set up, but I'd encourage you all to take a look at that. Really interested to see what kind of applications you can build on this, because the capability of pulling live blockchain data for analysis is one of the best parts of using Brownie. So take a look and let us know your thoughts on what you might build with this. Ask any questions in the comments.